Hey there, traveler! Welcome back to the GameDev Tavern, a place to relax as we build fun games together. My name is Nicholas, and this is episode 2 of the tutorial series where we build a pixel art beat-em-up game in Godot. In this episode, we'll start animating our player. Go ahead and hop over to the player scene and click on the animation player node. We can create new animations by clicking on Animation, New. Let's call this one Idle. Our idle animation is 4 frames long, so we'll make it 0.4 seconds long. Let's go ahead and set the snap to 0.1 seconds. This is also going to be an animation that loops, so we'll go ahead and press this loop button, and we want to make it the default animation for the player, so we'll go ahead and press this button right here. So when we are in animation mode, you'll see on the right hand side that the properties of the nodes have a little key that allow us to create keyframes in the animation. So we actually want to animate the character sprite and change the frame number depending on the frame where we are in the animation. Click over on the character sprite, and then here in the frame, you can see that we'll be swapping between 0, 1, 2, and 3. Go back to 0 and press this green button here to insert the first keyframe. The first time we add keyframes to an animation, Godot gives us 2 options. First, Bezier curves is for smoothly moving node properties from one frame to a different frame. On our end, we'll just be swapping image frames, so we actually don't need that. But then when making animations, we usually end up tweaking a ton of properties on the right-hand side. So this reset track is just an animation state that allows us to reset all of those properties to a predictable 0 state. Go ahead and click on Create. Now that we have properly set the first sprite frame to the first animation frame, we'll need to do the same for the other 3 frames. So we'll go ahead and select frame number 2 and hop over and select frame number 1 inside our sprite sheet. Click on the key again to insert a new keyframe. This is pretty redundant work, and so Godot actually makes it pretty convenient by increasing the number every single time we add a new keyframe. And so in order to insert frames 3 and 4, we can just click on this button 2 more times. Okay, with the animation set up, we can just go ahead and press the play button to make sure that it works correctly. And because it is the default animation, we can actually run the game, and we should see the player start animating. We'll do the same for the walk animation. Go ahead and select the animation player, click on Animation, New, let's call it this one Walk. Go back in the sprite, and here this walk animation is 0.8 seconds long because it takes 8 frames. We'll go ahead and start at frame number 10 and start inserting the first frame. Similarly, we'll keep all of those options, click on Create, and then we'll go ahead and move forward all the way until we've gone through all of the frames of the animation. This is also an animation that loops, so we'll want to click this button here, and we can test it by pressing the play button. Next, we'll want to either play the idle animation when we're not moving, or the walk animation when we're moving. This means that we need to introduce 2 different states in the code base, and have different logic for these states. In fancy terms, we call this building a state machine. In reality, it's just a glorified if statement in the code base. Before writing the code, we're going to draw a quick diagram of it so that it makes perfect sense to you. A state machine is a simple way to organize the logic of our game. We start off by defining the various states in which the player can be. At this point, we only have 2 possible states. The player is either idle or walking. For each state, we will be executing a different piece of code. When the player is in the idle state, we will tell the animation player to play the idle animation we just created. When in the walk state, we'll tell the same animation player to play the walk animation instead. The first rule of a state machine is that the character can only be in one and only one state at any given time. This makes sense if you think about it. You can't really be both idle and walking at the same time. Because we always need to be in one state, we'll need to define a state by default. We'll pick the idle state as the default state. Next, we will be defining what's called transitions. Transitions are rules by which we can go from one state to a different state. Our first transition will be from the idle state to the walk state. The rule for that condition to be fulfilled is that velocity must be different than 0. Our second transition will be from the walk state back into the idle state. The rule for that condition to be fulfilled is that velocity must be equal to 0. When in the idle state, as soon as the condition of the top transition is fulfilled, meaning the velocity is different than 0, we will go directly into the walk state and stay there until the condition of the bottom transition is fulfilled. So our state machine is quite simple at first, but even as it gets more complicated with more states and more transitions, it'll be an easy way to understand how our logic flows in the game. Now let's go ahead and write the code for it. Let's hop back into the script. We're going to need a reference to the animation player node so that we can change the animation inside the script. For this, there's multiple ways of doing it, but ideally what we'd want is a variable called animation player, and we want to actually set it to the node animation player. The problem with this is this node might not actually be ready when we call it here. So Godot actually has a separate special function called ready, in which the child nodes are already ready. And so here we could call our animation player and instantiate it to our node. Now this is a little bit cumbersome, and so GDScript has a very convenient way of loading variables once they are ready by using the onReady annotation. These 3 lines can basically be summed up as a single line like this. And then rather than writing get node, we're going to use the shorthand $, which is exactly the same thing. We now have a reference to the animation player, and we know that this will always be available when it's being called. The second thing we're going to do is we're going to start defining the various states for our character. For this, we're going to use an enumeration, which is a nice handy way of putting constants together that are related to each other. Let's go ahead and call this constant state, and we'll define 2 states, idle and walk. We'll then set the state of the player to the idle state. So as you can imagine, when we have the entire logic of the player inside the process function, there's going to be a lot of code here. So it's best practice to actually split it into multiple functions. Let's start by creating a function to handle the movement. So as we said earlier, if the velocity is null, then we're going to set the state to state.idle. However, if the velocity is different than 0, then the state will be state.walk. Next, we're going to create a function to handle the input. And this is going to be pretty much the same thing that we wrote in the process method. We're going to get the vector from the directional keys and assign a velocity to it. Finally, we'll just have a function to handle the animations. And here, now that we have a reference to the animation player, we can just tell it to play the proper animation. If the state is idle, we'll go ahead and play the animation called idle. If the state is walk, we'll go ahead and play the walk animation. Okay, and now that we have defined all of our 3 functions, we just need to replace them as part of the process here. So first, we'll go ahead and handle our input. Then we'll look at our movements. And finally, we'll go ahead and handle the animations. Go ahead and press F5 and see if this works. Okay, as you can see, when I'm not pressing anything, my velocity is 0, and so I'm back into the idle state. But as soon as I press one of the directional keys, my player starts walking. Now, it's a little bit weird because right now we're not telling the character to head one way or another. This is something we can easily fix. Going back into the 2D view, if you look at the character sprite, one of the properties here is flip horizontal. And when we set this to on, it just flips the sprite one way or another. So once again, going back in the script, we're going to need a reference to this node called character sprite. So similarly to what we did for the animation player, let's go ahead and create an onReady annotation. And set it to the character sprite node. Next, we'll create a different method here, and let's call this flip sprites. It's going to complain because we haven't created it yet, but let's go ahead and do that right now. We know the direction by looking at the velocity to see which way the player is headed. So the only thing we need to do is check if the velocity.x is greater than 0, in which case we know that the player is headed towards the right. When the player is headed towards the right, we don't need to flip the sprite. So we'll go ahead and set the character sprite dot flip horizontal equals false. Else, if velocity.x is lower than 0, let's go ahead and flip the sprite. You may be wondering why we're not treating the 0 case. Well, we actually don't want to change the direction of the sprite flip if we stop pressing a key. For example, if you start headed left and then you stop pressing the key, we want the player to stay facing left. Let's go ahead and try it out. Okay, so we can see that the player is now facing the right direction and we're playing the right animation when the player is idle or when the player is walking. Now you can also see that the player can hop on the wall up here and go out of bounds below the screen. So it's time to add some colliders and let the character body 2D do its magic. Hop over back into the stage scene and flip over the 2D view, and here we're going to create another container for our colliders. Control A, let's add a node 2D. Let's call this World Colliders. We'll go ahead and add two static body 2Ds. Those bodies won't need to move, so static body 2D is the perfect type for them. Control A, static body 2D, and similarly to the player character, every body needs a shape. So let's go ahead and hit Control A again, and let's add a collision shape 2D. On the right hand side, we'll go ahead and specify the shape to be a rectangle shape 2D. And then we're going to drag this all the way to the end of the level, and we're going to bring this down. To bring down an object, make sure to select the parent first, then hit the Alt key and drag it down to where the street level is. We're going to duplicate this and bring it below the screen. Go ahead and hit Control D to duplicate, and then Alt key, and then drag it down below the street. If you see on the right hand side, there's a collision tab which specifies the layers on which the object is and the layers with which it will collide. We're going to go ahead and give a couple of names rather than use those numbers. Go to Project, Project Settings, and then in the General tab, scroll all the way down to 2D Physics. And here we'll give it a couple of names. We'll have physical objects in the world, so let's call these World. Then we'll have a Player Collider, we'll have Enemy Colliders, and we'll also have props that will be destroyable. Let's call this Destructibles. Go ahead and close. So those two static bodies are part of the World Colliders. So let's keep them on the World Collider. And they're not going to be colliding with anything because they're not moving. So let's just remove this for now. If we hop back into the character scene, go ahead and select the character. Now remember that this is the base class which will be derived for both the player and the enemy. We shouldn't put in there anything that is not common across the two. Typically the collision layers is something that we don't want to specify. So go ahead and click in collision, and we're actually going to remove this from this base class. Go ahead and hit Control S to save, and then hop over into the player scene, and this is where we'll want to set the proper collision. We'll set that the player is on the player collision, and we're going to interact and collide with the world and the destructibles. We won't collide with the enemy right away. It's pretty typical for a beat 'em up game to allow the player to go through the enemies. Press F5 to try the game. As you can see, the player is now properly restrained at the top and the bottom of the screen. Two quick things. First, you'll see that there's a warning sign here, and we'll try to get rid of those over time. This one is complaining about the fact that we have this parameter delta that never gets used inside our function, and so we should usually prefix it with an underscore. Let's go ahead and do that. And secondly, one thing that I like to do is to keep all of the properties on the right hand side in alphabetical order, so we'll just move the damage above the health. Next up, we'll be building a camera that follows the player. Let's go ahead and create a new scene. And here in other node, we'll pick the node camera 2D. Go ahead and create it. We're going to save it, and we're going to go into the stage folder, click on save, and then let's hop over to the world and add the camera to the world view. So click on the world, Control Shift A, pick the camera, and let's go ahead and open it. Okay, on the right hand side, you will see that the transform of the camera is currently set at the origin. We actually want that to be centered on the screen, and because our resolution is 100x64, we'll just set the position to 5032. We now have our camera here, and whenever we play the game, it will actually display the content of the camera. We want the camera to follow the player, and actually we'll want it to only follow the player and move forward when the player is moving forward. Typically in beat 'em up games, we don't want to allow the camera to go backwards to force the level progression throughout time. There's multiple ways that you could do this. One way would be to add a script to the camera scene and force it to know about the player so they can follow the player. Actually, let's do that now. So I can show you how this is done. So let's go back into the camera scene. By the way, we'll just rename this camera go ahead and add a new script. Let's call this camera instead. Create, and let's get rid of all of this. So the camera will need to know about the player. So our player will be a variable of type character body 2D. And similarly to how we were able to export some properties like the health and damage, we can also export this player property so that we can have a reference to a player that we can add on later. So when we type export here, we now have a reference we can assign. So when we're back in the world view, our camera can just go back to the 2D view here. Our camera can assign the player, and whenever the camera starts, we'll now have the player properly assigned to the camera. As part of the script, we'll just have some simple logic to define the fact that if the player is further to the right than the camera, so if the player position.x is bigger than camera's position.x, then we'll just realign the camera's position with the player position. Okay, we can press F5 and try this out. And you'll see that it should be working properly. The camera follows the player and never allows to go back. However, there's two concerns with this. First, we're now starting to add a lot of logic that is dependent on the player inside the camera. And there's a concept called separation of concerns, which is objects should really only be concerned about what they're good at. And the camera it's not really its role to know about the player. And there's a lot of logic we could be adding. For example, sometimes we'll want the camera to stop moving when the player is fighting enemies. We don't really want that logic to be in here. The second is we just built some hard coupling between two siblings. Now the camera can only exist and work if it knows about the player. This prevents us from moving the camera elsewhere or have different sort of behaviors. So this is something that we typically want to avoid. We don't want to have hard coupling between siblings. The best way I found to tackle this is to actually put that logic as part of the parent. The parent knows about the two children, and the parent will know when it's time to move forward for the camera, when it's time to follow the player. The world is really where all of the game logic is going to happen. So rather than have a script as part of the camera and have a reference, we're going to actually delete what we just did. So let's delete the camera 2D here and go back in the scene. Let's close this, and we're going to just remove the script and the scene altogether. All right, so here we're going to add a child as part of the world, and let's go ahead and hit Control A. Let's add the camera. Let's rename it camera. And now we're going to create a script for the world. All right, so we're going to get rid of all of this. And similarly to how the player knew about all of its children using the onReady variables, we're going to be using the same annotations here to have references to both our player and our camera. Now, as part of the process method, we're going to have the same logic that we just wrote. So if the player.position is larger than the camera's position, then we'll just move the camera. All right, and this will work exactly the same way. So we need to move the camera so that it's centered on the screen. So go over to camera, hop over to transform, and let's set it back to 5032. Now press F5. And this should work exactly the same way, except we've gotten rid of the hard coupling. The camera doesn't need to know about the player doesn't need to know about the camera. That's none of their concerns. That's the concerns of the world to know when we're moving forward, when we're done with the game, and so forth. This is a nice way of just decoupling logic. We'll be using that principle throughout the entire game. So you may have noticed that when we play the game, the camera follows us forward, but the player is still able to go out of bounds by going left to the screen. And if we're to lock the camera in place, the player would be able to go towards the right of the camera as well. So we want to add some sort of invisible walls to prevent the player from doing this. And those invisible walls will move alongside the camera as well. Let's start by creating a container object for those two walls. So let's add a node2d, and we'll call this invisible walls. Let's start adding the wall on the left. So for this, we'll be using a static body, adding a collision shape, hop over into the shape, and let's pick a rectangle shape. Clicking here will allow you to define the size, and let's make this 6 pixels wide by 64 so it goes across the entire screen. Then pick the parent here and let's move this down by half of the vertical screen. So bring it down to 32. Okay, and let's call this left wall. Then Control D to duplicate it, and we're going to move this towards the right hand side. So we'll just set the location to 132. Okay, we now have our invisible walls here, and we want that to move forward with the player, with the camera. Basically, it's going to follow the camera along. And there's multiple ways to do this. Godot has a node called the Remote Transform 2D that allows us to do this. We could also write the code for it similarly to how we moved the camera according to the player. I'm actually not sure what is the best way to do this. For now, I guess the simplest way is just to make the invisible walls a child of camera. We can start with that, and I think down the line, if we see that this is causing some issues, we'll be able to fix this. But go ahead and start the game. You should be able to see those walls follow the player along, and it will prevent the player from moving back. Let's make sure to rename this right wall, and we'll also take care of this quick warning here. And similarly to the first one, because we're not using this variable delta within our function, we'll just prefix it. All right, this is going to be it for this episode. We finally got an animated character that the player can move around, with a camera that follows them as they move forward. We talked about state machines and a few best practices. And my hope really through this series is that you fully understand every single line of code that you write. So if you have any questions or comments regarding something you don't understand, please ask away in the comments section, and I'll do my best to respond quickly. Thanks again for watching. The GameDev Tavern is a brand new YouTube channel, so any like or subscribe click would go a long way in helping it grow. Once I reach 1,000 subscribers, I'll have you pick the type of game or engine you'd like me to build a tutorial for. Time to take a quick break. See you in the next one. Cheers!